I don't think it's actually as relevant today as it was in 2022. But this person who wrote a blog post, Bruce Dawson, September 29, 2022. He made a blog post here about Windows Voice Recorder, and he noticed that there was a huge delay in Windows Voice Recorder loading up and starting. He wanted to record himself talking about something. And so then he did kind of a deep dive. So for the people who are not programmers, you can just kind of glaze over this for a minute. We'll just cover this briefly. I thought it was a very good kind of like a deeper dive into what the hell Windows is doing in 2022 with something as simple as Windows Voice Recorder. So he started it up. There was a long delay before it would respond. A 20-second delay for recording a 40-second clip is a pretty bad efficiency ratio. He pulled up an ETW trace. An ETW trace is a way to kind of break down all the different components in the Windows system that are running as you're running like one of these executables. So what he did is he found soundrec.exe, and then they were verbosely named runtime broker.exe. It's kind of tongue-in-cheek, Microsoft Windows Sound Recorder. Looking at its CPU usage, I noticed that it got busy as soon as I launched it before I clicked the record button. Why? There was something happening that was CPU bound, spending most of its time on a single thread that was busy performing queries on the results of a crawl over some directory. And so here you can kind of see the breakdown of what it was doing. So then he looks at the file IO graph. What's it looking for? It was a bit inconsistent, but it was scanning part or all of my documents directory. Meanwhile, another runtime broker thread was spending a bit of time in process.dll, try get file type association from state repository. What the hell is this? So it was trying to find all audio files in the documents folder so that it could list all the previous recordings, as can be seen right over here, right? So as it's doing that, there was a significant delay. That's where the delay came from. Once you allowed for the list of recordings to build up, which means that these processes finished, the scan was done, then the recording would start instantly. And then he has some sarcasm that I really, really enjoyed here. Clearly, this was a case of user error. If I had waited patiently for my slow computer to be ready, then it would have been fast and responsive when I wanted to start recording. Of course, right? So how on earth is it okay for this kind of a system to take 20 seconds, anywhere between 20 to 40 seconds, to scan your documents directory in order to find associated recordings? That's insane. And he proves this, right? If he runs dir/s on his documents directory, it takes less than 2 seconds. Why is Runtime Broker taking 5 to 10 times more in order to scan it? There's 44,000 files. That should be nothing. Why does Runtime Broker scan the entire documents directory instead of just like the sound recordings file or folder, right? What happens when users don't have an SSD with 32 gigs of RAM? In my case, he says right here, the entire structure of my documents directory was entirely cached in memory, so there was zero disk activity required to do the scan. But some users are not so lucky, especially if you got to spin that disk to get to the right point. When doing an operation that blocks the user from using the application when a progress meter or busy cursor would be more honest. So instead of just freezing the app, why don't you just show that there's something happening, right? Record, for example, disable the record button until it's ready. Why does the scan of documents directory sometimes not traverse the entire directory? Is there Runtime Broker caching? So he breaks this down really, really nicely. And you know what I thought particularly interesting? Just really briefly before we jump into technocracy here, just really interesting. The Hacker News article here is just really funny. So we have, like, right up at the front here, alternative hypothesis, brace yourselves. People don't care enough. Any vendor will prioritize requirements if performance is not there. That CPU and memory is going to be used if in any way it helps the developers. Conversely, by looking at a system, you can infer its requirements. For commercial airplanes, it may be safety first, ticket price second, passenger capacity, fuel efficiency, and speed third. For most software functionality, signing up for a subscription, platform availability, etc. are usually prioritized higher than response time and keyboard shortcuts. Game devs worry a lot about latency and frame rates, and professional software care a lot about keyboard shortcuts. This proves anecdotally that performance isn't achievable at all, but isn't unachievable, but rather deprioritized. Nobody actually wants slow apps. It's just that developer velocity metrics are higher priorities, and it comes with the CPU and memory costs that the vendor doesn't care about. To consumers out there, you know what this is saying? Vote with your dollar. Stop accepting this shit. Stop buying this crap and start complaining. If something is slow and buggy, don't just go like, oh, this is just how it is. No, consumers out there, please. You don't have to know anything about programming. I beg of you, complain as much as you can. Try to avoid spending your money on stupid, buggy, slow, insecure shit as much as you possibly can. Because then these people who prioritize the ads and subscriptions and, shipping it out fast and whatever are going to change their tune, and you're going to get a much better product out of it. I guarantee you. So please, as consumers, and that includes programmers, vote with your dollar and complain. I'm a game developer, and game performance is better than ever. It's better than ever, Gear Games. 144 hertz monitor, 4K, we got you covered, bro. Even ray tracing and VR is on the way. Most games render frames of a 3D world in less than 17 milliseconds, but most websites take 3 to 7 seconds to load because of all the ads and bloats, but things shift around on you for another 20 seconds after that. So, when you go to tap a link, you accidentally tap an ad that finally loaded under your finger. If you optimize those websites, they run super fast though, but it's quite a pain to do with the dependency bloat in modern tech stacks. Note, games lag as well when you drag in a million dependencies you don't need. The thing is, most sites and web apps try to solve a user problem, and if you're the only company in town that solves a problem, then performance barely matters. What matters is solving the problem. The users will put up with some pain because the problem is even more painful. With games, it's all about the experience of interacting with the software, so performance is, hopefully depending on your team and budget, amazing. That and performance tuning is hard work, and I think most people don't know much about it. It's a fractal rabbit hole. Cache misses, garbage collector, streaming, object pooling, dealing with stale pointers, etc. Even I have a ton to learn, and no matter how much I learn, I probably still will have a lot more to learn. It's easier for many teams to hand wave it, I guess, as long as they aren't losing too many customers because of it.